Hi, welcome to another lesson at EDU Solutions Institute. Now, in this week's lesson, we are looking at the CSEC physics syllabus on the topic of work and energy. Now, on last week's lesson, we calculated the principle of momentum by using elastic momentum or inelastic momentum. So if you haven't watched that video, you can just pause this one, go over and check out that video. Because let's resume on this week's lesson of work and energy. What does the concept of work mean? Because we always say we're doing this work, we're tired of doing work. What does that mean in the scientific term? Now, in physics, we say that work is the effect of applying a force to cause an object to move. So when we're doing work, right, just simply walking, we are utilizing a force to cause our foot to move us from one point to the next. And hence, we say that is doing work. And the amount of work is dependent on how much force we use to move, as well as how far we're moving. Are we just moving right here, or we're taking a run or walk down to the road? So therefore, work is dependent on the force applied and how much distance is moved. So therefore, to find work, capital W, it's to multiply the force by the distance that was moved. And this tells us that the unit that we measure work in would be joules. Or in some cases, you can ask what's another name for joule or unit for joule, which is Newton meter. Newton for the force and meters for the distance. Now, with work, we have the principle of energy as well. And energy, in simple terms, it's the ability to do work. Which means if you don't have this, you cannot do work. So it is more of a property, where energy is a property that you have to have in order for you to do work. Alright? So in terms of energy, we have different types of energy. Right? So we have a various amount, even more than this, about the types of energy. Right? So the first one is potential energy. Now, potential energy is just stored energy. This means that it's energy that is stored inside the object to be used at a later date. Right? Now, we have different types of potential energy. One that we're going to look at is elastic potential energy. And this type of energy is the energy that it is stored up within elastic objects. For example, an elastic band, right? So it stores energy when we pull it, right? So therefore, when we release the object, that energy is used now to get it back to its original shape. So that's what the elastic potential energy is, the stored energy inside elastic objects to get them to return to their original shape. Then we have the gravitational potential energy. And these energy are the ones that we have due to our difference in height. So if we have an object on the ground and we lift it to this height, then therefore it now has some gravitational potential energy. Right? So therefore it's stored energy that's inside this object that when it's going to fall, it's going to use that energy to fall to the ground. So the principle of knowing, do we have gravitational potential energy, is can the object fall to the ground? If it can fall to the ground, then it has gravitational potential energy. So once it's above the surface of the ground, then it has that form of energy. Electromagnetic force or energy, sorry. So electromagnetic energy, these are the energy that is in our electromagnetic waves. Example would be light waves, right? This is the primary one that we use regularly. So light waves have light energy, right? And these energy enables us to see objects. So you can see things in colors, right? So it's the energy that is inside this type of waves that enables humans or animals and alike to actually see things. Thermal energy, which in terms is called heat energy. And these energy are created when objects vibrate. So the vibration of objects causes it to release thermal or heat energy. And then we have sound energy, which is the energy that is traveled by objects vibrating that enables us to hear. Then we have kinetic energy, which is the energy that objects have due to their motion. So once objects are moving, then they have what we call kinetic energy. We have nuclear energy, which is the energy that is stored inside the nucleus of atoms. Right? So this is the energy that keeps the neutrons and the protons together inside of a nucleus of the atom. And finally, we have our electrical energy. And these are energy that is carried by charges inside wires or conductors. Right? And there is one more that I didn't add, which is chemical energy. And chemical energy is the energy that we have in the bonds of chemical compounds. So in simple terms, when we eat food, we get this energy from our food that we eat, because we break down the food in terms of its molecules, its compounds that they have, so we can get that specific energy from them. Right? So those are the popular types of energy that we will talk about in physics from here. Now, if we go further, we look at the two main types of energy that the syllabus focuses on. How do we find the gravitational potential energy, which we abbreviate GPE? And this is the mass of the object multiplied by its gravitational acceleration, which is always on Earth in most cases, which would be 10. And then the height would be what's the difference in the height that the object moved. So therefore, if it is here and it's falling to the ground, it's how the distance from here to the ground is. Or if it's from here and then it has a shelf here that's going to fall to, then it's how much it's going to change to reach to the shelf. And then for kinetic energy, which we abbreviate KE, this is calculated by half of the mass, so half times mass times velocity or speed squared. Right? So notice it's only the speed or the velocity that is squared, not the mass as well. So that's how we find our kinetic energy. So that tells us if you're moving fast, then you'll have more kinetic energy. If you're going slowly, you'll have a small kinetic energy. Now, it is always good to know that work done is the energy that is being used. So if we do 10 joules of work, then that means we have utilized 10 joules of some form of energy, right? So therefore, how much energy you've used tells us how much work we have done. And therefore, that leads us into all the practical examples that we will do at this level to tell us that in energy conservation, where energy is changing forms, it will always change from potential energy to kinetic energy, and it tells us that there is no energy lost. Right? So in a no energy loss system, then the potential energy that an object has at a specific point will equal to the kinetic energy when that point is finished. And let's look at an example over here. Now, we call this the conservation of energy law, which tells us that energy cannot be created or destroyed, but it's changed from one form to another. And what this means is if we had 100 joules of chemical energy, we do not destroy that 100 joules of chemical energy or create more on it, what we do is to convert other energy forms into chemical energy or the chemical energy into other forms of energy that we have just explained. So let's look at this situation. So this is a waterfall. All right. So at the top here of the waterfall, the water is primarily relatively not moving. So we're going to see that the kinetic energy here is 0 joules. But because it is above the ground, then it has some stored gravitational potential energy. We're going to use 1000 joules for this case. So hence we can see that the total energy here is 1000 joules. So according to the law, we will always have 1000 joules of energy. But what's going to happen is that it's going to change forms. Now, we're going to just use these two types of energy. So therefore, in the middle of its journey down, it's going to now accumulate some kinetic energy because now the water is moving. So the kinetic energy will be half of what the total energy is, and therefore the gravitational is reducing because it's now getting smaller in height. Right? So here it was a larger height. When it reaches halfway, it's now half of the height. So therefore, it's now half of the energy that was there before. And again, if we add these, we get the total energy that was in the system. Now, when it reaches the ground and right, then these water particles have no gravitational potential energy because there is no height. It's now on the ground. So therefore, if it has 0 joules of gravitational potential energy, then it must have 1000 joules of kinetic energy because the system has to maintain the 100 total joules of energy. So what we see here is this principle, that the total potential energy at a point will be equal to the kinetic energy at another point. And in this case, at the start, it had a maximum potential energy. And then when it reached the end, it had its maximum kinetic energy and 0 potential energy. So that's how the principle of energy works. Now, stay tuned next week as we're going to utilize these two formulas with some specific questions. So see you next week as we explore more on the principle of energy and work.